Now next topic is superposition principle. According to this principle, when two or more waves are traveling in a medium, then their resultant displacement is given by the vector sum of the individual waves. That is y is equal to y1 plus y2 plus y3 plus so on. Now let us consider this. For example, we are having two waves which are having same amplitude moving in opposite direction to each other. Okay, opposite direction as shown. Here you can see here, suppose we are having a wave pulse this, and another wave pulse is this. Okay, so this is wave pulse P of amplitude capital A, and this is wave pulse Q of amplitude A. These are moving in opposite direction like this. Now let us consider that these two wave pulses are at an instant of time t. After some time, since they are moving opposite to each other, they will superimpose. They will come closer to each other as shown. P will reach this point and Q will reach this point. Okay, so this is P and this is Q. And after a later time, both of these superimpose and give a resultant wave of amplitude 2A. And after that, Q will come to this side and P will come to this side. Means they crosses each other. So this is how superposition takes place, and in this case y is equal to y1 plus y2. Similarly, if two waves are of same amplitude but of opposite sign like this. Now here if we are having two wave pulses, P is positive and Q is negative. Both are having same amplitude A. This is A, P wave, Q wave. Both are moving in opposite direction. So after certain time, when they superimpose, P come closer and Q also come closer. And after some time, they overlap and resultant intensity is 0. And after that, Q will come this side and P will come to that side. So they cross each other. Now here resultant intensity is 0. So y is given by y1 minus y2, where both y1 and y2 is equal to A. So hence the resultant intensity is 0. So this is all about the superposition principle, and applications of simple superposition principles are applications. First is stationary waves, beats, and interference of waves. We will study these two in this chapter. Now to study about the stationary waves, firstly we need to understand the concept of reflection and refraction of the waves. So for the reflection of wave, here reflection of wave. Reflection of wave takes place for both the transverse as well as the longitudinal waves. And it is found that when a wave gets reflected from the rigid boundary, a phase change of pi takes place. Okay, so to understand this, so in short we will write a phase change of pi takes place on reflection. Phase change of pi takes place on reflection. Right, now to understand this, let us consider a wave pulse moving toward left and hit the rigid boundary. This is a rigid boundary or wall boundary. Okay, when it come closer and hit the wall, in this case it will exert a force F on the wall in the upward direction. Now since the support is rigid, so it will remain unaffected, and in turn it will give an opposite reaction in opposite direction, and the pulse will move in the opposite direction with this force. So you can see that if a crest strike the rigid wall, in turn we get a trough, and hence a phase change of pi takes place. As in this case, when a crest and then trough, there is a total phase change of pi in between the crest and trough. Hence the phase change of pi takes place. And similarly, if we are having the sound waves like longitudinal waves, in that case, if a compression strikes the rigid boundary, a rarefaction will occur, and hence the phase change of pi takes place. Similarly, we can also prove that in case of refraction at the open boundary, okay, no phase reversal takes place. In that case, the arrangement is just like a pulse is moving and the other end is free to move across this road, right? Means this road is in passing through this ring. Now when this pulse strike reaches at this end, it will exert a force F. Since the boundary, the string is free to move, so it will take the ring to up and it will come down with the same force, and no opposing force is acting. So again we get a crest. So in case of refraction of sound waves or waves, we get no phase reversal. No phase reversal. And hence we can say that a phase change takes place on the reflection and no phase change takes place in case of refraction of waves.